In this video, I look at the net utility in the ESP-r simulation suite. It was intended as an alternative graphical approach for defining networks of airflow nodes and components. After all, users often sketched an overlay over their model for planning purposes, so it was envisioned as a starting point for setting up the basic relationships which would later be fleshed out by other tools and by folks who had a more detailed appreciation of flow patterns. It was icon-based, where each icon encapsulated the attributes of a specific component, say a door or a duct section. Assessing flow patterns resulting from, say, the controlled opening of windows has always been a classic project for mass flow networks. The trouble was that utility net application was rarely used, and often sometimes only for the most trivial of flow regimes. Lots of simulation suites have their forgotten corners, with facilities desperately needing a refresh. Perhaps because, well, its data model failed to evolve with the rest of the simulation suite. Or perhaps some choices in their interface kept responding with the message "work in progress." Or perhaps because some immature facilities were actually not marked as work in progress. And I, for one, hate it when I have to open up another tool or look in a QA report to find some area or volume. And a classic failure of orphaned facilities is that they are stuck in a one-way communication loop. They could send information to other applications, but would lose information if they tried to re-import updates made in those other applications. I can count on my fingers and toes the number of times I brought this particular utility in my workflow. Because of those perhaps because issues, yep, it was chunky, somewhat incomplete, a bit frustrating to use. And for ages, it was really tricky to find the resources necessary to shift the inertia within the application itself, the infrastructure it relied on, or to get it to a point where we might contemplate shifting the habits of the user community. So why revisit this utility? Or indeed, why make this video? I hold a rather unfashionable belief that there is little point in creating a high-resolution description of the form and fabric of a building, or detailed control logic, or of an environmental system, if a big part of the energy balance of the model is based on an arbitrary thumb-suck approach to the movement of air. One of my other day jobs involved a decade of hosting physical and virtual workshops for professionals getting up to speed with Passive House. And one of the more tenuous tasks in those workshops, and indeed in the deployment of almost any high-performance building regime, is understanding the risk of overheating. And lots of the professionals in those workshops, well, they weren't particularly skilled at designing natural ventilation schemes. Now, the usual compliance workflows are, shall we say, challenged in terms of overheating risk assessment. The powers that be want to nudge builders and designers to go for high-performance facades, but they insist on putting off dealing with the elephant in the room, that overheating risk. My numerical tool of choice for natural ventilation studies has long been ESP-r. Of course I would say that because I'm one of its developers, and I've carried out scores of consulting and research projects with it. The folk who wrote the underlying solution techniques and the data model were actually quite good at what they did. Midway between options for designer deities who insist on imposing their own flow rates on the building and the CPU melting realm of CFD, There's network flow. It's an approach to describing airflow paths and effectively solving mass flows in a building, and it does so very efficiently. The context, say, I could solve a moderately complex flow network with, say, a 1-minute time step over lots and lots of months, and that would take roughly the same time as to solve maybe a moderately simple CFD domain over a few time steps. The simulation you just saw was based on a network created from attribution embedded within the simulation model. For example, that a surface acts as a door which has, say, an undercut, or which is slightly open. Unfortunately, quite a few users find airflow difficult to master. And there are some valid reasons for this. There is a bias in the tool that misses out whole classes of potential flow paths and flow inducers. And then, well, there's the frustration of being asked questions like, oh, what's the hydraulic diameter? What are the dimensions? And what are the coefficients of that particular junction? To be able to switch to an icon-based model for such entities and perhaps inherit some curated attributes, well, hey, that would be a great option. And now a bit about how the sausage was made. Suffice it to say that revisiting a code base and data model from a decade ago required a bit of archaeology. And I also considered what might make the underlying structures and facilities like Icon Database a bit more fit for purpose. For example, what is known as a Type 40 common orifice to the flow solver, well, it might represent a door undercut, or a trickle vent, or openings into sash windows. And if the user had a specific context in mind when they selected the icon, surely there should be an option to reflect this, and that would lessen the opacity of the network. In the event, quite a few icons have been reimagined, and some low-level code has been adapted. Ease this process, I made a Python application to help with the creation of the vector commands on which the icons are based, and it also generates the blocks of C code needed by the simulation tool interface. Ensuring that the two-way passing of information between the various modules of ESP and the net utility was possible without the loss of information, well, that was a big part of the work. And I tested this by doing a round trip on scores of existing flow networks and checking what worked and what processes failed. In short, the evolution of the net utility for use for workflows touched a lot of corners in the simulation suite. And honestly, well, there's no better way to identify and smooth out frictions than to force yourself to create a video about what will become available in the next release and how you might give a taste of what workflows that new facility might support. Let's use this evolved beastie. A good place to start is pulling together in one menu all the various options for treating airflow within ESP-r. Within the net utility choices are common tasks which should be straightforwardly invoked. The first of these options is to simply begin with an empty grid. Well, let's open up such a session and play around with the various facilities for creating nodes and components and linking them together. After selecting empty network, basically I'm asked for a suggested name for a network file and something called a .summary file, which will pass information to net related to aspects of the model that might be useful later on. The net utility starts up. We're presented by a grid that we can place items on and a menu on the right which allows us to set some basic parameters and then toggle between different working mechanisms, like picking our primary interaction by way of a mouse or menu commands, Below that, we have a toggle between nodes, components, and connections. And other items below change depending on what our focus is. So let's add a node, and we have a category of internal nodes and boundary nodes to choose from. We've got two choices, unknown variable pressure or known fixed pressure. Normally for a thermal zone we would pick unknown variable pressure. And we place that node on the grid, and then we're asked whether we want to carry on manually editing that node or use details from the model that would have been passed in. If we choose to inherit the information, it comes up with a list of the thermal zones, what their volume and average height is, and we would pick from that. It asks us if we want to inherit the information, and of course it notices that the actual thermal zone is in a slightly different location, and once we accept that, it places things into there and also associates that icon back with that thermal zone. Let's add a wind-induced pressure node to this grid. So I'll click on a location. And I'm asked to name it. Now, this is going to be one I'm going to call South. And I want to change the azimuth to reflect that, so 180 degrees is appropriate for that. Let's go to Components and add a component. We've got level choices here, basic ones, or we could set up, say, a crack. And here's a list of ones that we could choose from. 1 millimeter by 2 meters long. And again, I place that on the grid. And I inherit a name. In this particular case, I edit that just slightly. Okay, now I could toggle over to Connections and add a connection. Let's select it by menus. So I want to go from the south boundary condition to that zone called box, and I've got this one component to do it, and it sets up a connection from that. The tiny little squares are intermediate points that I could drag around to make it a little better. Now, if we save this into a file, it will also at this point create an airflow file for use by the project manager. If I exit from this, I'm asked, do I want to merge the changes? I'm not yet done with it, so let's just hold off on that and not embed it back into the model. There's a session finished. Let's start a session. I'm using a slightly different model this time, and we're going to go into the network flow, and we're going to start one with nodes and potentially ambient layout. If I choose that, it asks, do I want to create wind-driven boundary nodes? And I say, yes, go ahead and do that. And I say no to the next question. And then I will be typing in the name of the file plus the summary file. I'm going to put that in the nets folder. And we'll drag that in there. Now, I only see a few nodes in here, so I'm going to go to the zoom, and I'm going to zoom out a little bit to, say, 0.5. When I click OK, I can see I've got 3 nodes, plus I've got some boundary nodes set up there. Now, if I edit, say, and click on East, well, there's all the information for that particular node. And say I want to edit another node. Here's a zone node. Again, that's got the various information in it that I was expecting to see. So there are no components in here. Let's add one. Let's stick a door on the end zone there. So there's a door, not very big door. I'd have to go in and edit it later on. Well, I'll set it somewhere in between those two, and there's a default name for it. And then I will then go and double check the information and switch to connections, add connection, as I did before. I want to go from south. Where is it? There we are. And I want to go to NZ. And there's the door I just created. And it's created that linkage there. Now, I'm not done. Don't need. So, when I exit back out, I'll say no to recovering that information, because I'll want to go in back later on. Now let's do a session picking up from earlier work. I choose the Via Existing GNF File option, and I'm presented by a list of files that are available. When I choose that, it starts up the utility with the grid from that prior session. The first thing I want to do is to nudge the y-axis so I can more easily see the selection I want to be working on. And I'll also zoom in a bit as well. In this case, there's a node called heater, which happens to line up with the space above it, and it's difficult to see. Let's do something about it and see if this change is reflected back into the model. So, if that node was actually visible, I could simply right-click on it to move it. But if we switch to the list selection, I've got another way to accomplish this task. Set the toggle to list select, choose the edit node data. From the list, I select heater, and I want to alter its position in space, shifting it downwards and to the right slightly. To do this, I simply edit the X and Y values. This change shows up in the node data, and let's save it. Now, the saving process also generates both a legacy and a current flow network file, and I'm asked to confirm the names of the files. On closing the utility, the project manager asks me what to do. Now, viewers who've been paying attention will notice this dialog is a bit different from an earlier session. I decided to change it. I added a choice of reading either the graphic file or to use the network flow file that was created. This is the same code used to do the conversion within the utility or within the project manager. You can choose which one you want to do. The other change is to save you from having to remember the names of the files that the utility created. Well, we'll just pull up a list to select from rather than forcing you to type it in. And there follows a few interactions to confirm which thermal zones are linked to the nodes in case you might have changed those. So, has that trivial change shown up? Well, I'll go into the 3D menus option. And then I'll check the nodes menu. And let's see. Yes, the heater node position has indeed changed in that. And it's also been repositioned in the wireframe view. The ability to carry out a round-trip evolution of leakage characteristics in a building, well, hopefully that will allow you to choose which tool is the most convenient to use for your specific workflow. And the next release of ESP-r should include this facility.